Today, we're also announcing a new $1 billion climate innovation fund to accelerate the development of carbon reductions and removal technologies.
Carbon capture and removal is getting a lot of attention, from oil giants.
ExxonMobil and a company called Global Thermostat announced an expanded joint development agreement to advance and bring to scale breakthrough technology that removes carbon dioxide directly from the atmosphere.
To tech visionaries.
Elon Musk offering a $100 million prize for the best carbon capture technology.
And airlines.
If we're going to solve carbon, we have to use direct air capture and sequestration to take carbon out of the atmosphere and permanently store it in the ground.
Government support of the industry is also growing. Last year, Congress authorized nearly $450 million to be used over the next 5 years in the research and demonstration of large-scale carbon removal.
You're seeing a lot more action, and I think a lot of that was really spurred by some of those reports that said, this is not a technology that's nice to have, this is a technology you must have.
In a 2018 report, the Intergovernmental Panel on Climate Change said that lowering our carbon emissions is no longer enough. If we're to limit global warming to 1.5 degrees Celsius and avoid the worst effects of climate change, we need to actually remove between 100 and 1,000 gigatons of carbon dioxide from the atmosphere over the 21st century.
We were actually assessing a lot of different pathways to reach 1.5 degrees C, but none of them could actually reach the temperature target without removing CO2 from the atmosphere.
Carbon removal can be done naturally by planting trees or improving carbon storage in the soil through more sustainable farming practices such as crop rotation and improved cattle management. But a number of companies are also working on engineered solutions to carbon removal. The process, which is known as direct air capture, sucks CO2 straight out of the atmosphere. Today, the cost of direct air capture is more than 50 times the cost per metric ton of most natural climate solutions.
Cost estimates for direct air capture really range from about $300 to $800 per ton of carbon dioxide.
Direct air capture creates carbon dioxide as a byproduct, and companies are selling it for a variety of purposes to offset costs. But some experts say this can be counterproductive.
If you're just removing the carbon from the air, spending a lot of money, and not selling the carbon dioxide for some purpose, there's not even a business model for that. So they have to sell the CO2. So what's the best use of CO2 right now? Well, it's to actually pump the CO2 in an oil well and to make the oil less dense so it'll float to the top and make the oil well more productive. So this is called enhanced oil recovery. The oil companies love this because they actually can then take the CO2 and then increase their oil production, which means we'll burn even more CO2, burn more oil for transportation, other uses, and that will result in even more air pollution and global warming.
The terms carbon capture and direct air capture are often used interchangeably, but they're not the same thing.
Carbon capture refers to capturing carbon dioxide emissions at the source, so at industrial and power plants.
Capturing carbon from the smokestacks of industrial plants is not a new technology.
Decades ago, oil and gas companies had to figure out how to pull carbon dioxide out of products that they were trying to produce. And so they developed technologies to do just that. Now, separate from that, oil and gas companies also discovered that when they were trying to produce oil from depleted fields, if they pumped carbon dioxide down into the rock, they were able to get more oil out of it. And so it was in the 70s that Chevron first actually combined these two technologies and piped in carbon dioxide from plants that were gas processing plants and pumped it down into an old oil field.
Unlike carbon capture, which removes new carbon emissions, the main appeal of direct air capture is that it removes excess carbon dioxide that has built up in the atmosphere. Direct air capture is not yet widespread. As of June 2020, there are only 15 operational direct air capture plants in the world, but a number of startups are working to perfect the technology. CNBC spoke with 2 leaders in the space to see how they plan to bring direct air capture mainstream. Canada-based Carbon Engineering has been experimenting with direct air capture since 2015. CNBC visited the company's pilot plant in Squamish, British Columbia back in 2019. At the time, the pilot plant was capable of capturing 1 metric ton of CO2 per day. Now, Carbon Engineering is working on building a commercial facility in the Permian Basin with partner Oxy Low Carbon Ventures, a subsidiary of oil giant Occidental. According to Carbon Engineering, once the plant becomes operational in 2024, it will be able to capture up to 1 million metric tons of CO2 per year, which it says is equal to the CO2 that would be removed by 40 million trees, or by taking 250,000 cars off the road. The company's method for capturing CO2 works something like this. Large fans suck air into a machine known as an air contactor. The air then passes through a honeycomb plastic surface that's covered in a carbon dioxide absorbing solution. The resulting solution is then processed in a few more chemical steps to create calcium carbonate pellets, which are then heated at an extremely high temperature to release CO2 in pure gas form. The solution is recycled and the process restarts. It's a very energy-intensive process. Carbon Engineering's pilot plant is powered through a mix of natural gas and renewable energy. The company plans to do the same with its commercial facility, though it hopes to eventually run that using 100% renewable energy. After capturing the CO2, there are several things that Carbon Engineering can do with it. The first is to inject the CO2 deep underground into saline formations, as well as old gas and oil fields, where it can be permanently stored. The practice is considered carbon negative since it pulls existing CO2 out of the air and locks it away for good. Part of Carbon Engineering's business plan in the future is the sale of carbon credits, which companies can purchase to offset their own emissions. Shopify has already agreed to be a customer. Virgin is also giving members of its Virgin Red loyalty program the opportunity to use their points and have Carbon Engineering remove carbon molecules from the air in their name. Another option involves using the captured CO2 as a feedstock and combining it with hydrogen to create synthetic fuels. These fuels can be used to power existing gasoline and diesel vehicles, as well as planes, which are difficult to electrify. Carbon Engineering argues that its process results in a carbon-neutral fuel, because even though the synthetic fuel releases CO2 when it's burned, the carbon used to create it was first taken out of the atmosphere. Carbon Engineering has been experimenting with manufacturing synthetic fuels since 2017, but the company is not selling its fuels because incentives that would make the fuel competitive are lagging.
So in the United States, we have the Renewable Fuel Standard, where the federal government incentivizes the production of sustainable fuels, but air is not included as a feedstock. So when I go and compete in the United States, my competitor who makes fuel out of corn or palm oil or renewable city waste, they have a significant government subsidy advantage.
Lastly, some of the CO2 that Carbon Engineering captures is sold to oil companies for enhanced oil recovery, or EOR. The practice is highly controversial and has led some experts to question the benefit of direct air capture.
In the United States, 50,000 new oil and gas wells are drilled every year. And under direct air capture, those wells would continue. You'd have 50,000 new wells every year because you're not stopping the fossil fuel industry, you're actually promoting it by allowing it to continue and by allegedly removing carbon from the air, but not actually stopping the fossil fuel industry or its mining, transporting, and refining of the fuels.
But Carbon Engineering says EOR is necessary until more stringent policies regarding carbon are put in place.
Why does our first plant have an enhanced oil recovery element? It's fundamentally because the policy support for capturing CO2 today doesn't quite equal our costs. So doing that with our first plant closes the gap on the first plant economics. Moving forward, our costs drop. So then enhanced oil recovery is an option, but it's not a necessity. And what we hope is we see a growing market for pure sequestration, where you simply remove CO2 and bury it permanently underground, but it's not quite there yet. The interesting thing when you do enhanced oil recovery with atmospheric CO2 is you capture more CO2 from the atmosphere than is contained in the crude that comes out. So what that means is you've effectively made carbon neutral fossil fuel.
Carbon Engineering says the cost for capturing carbon using its technology ranges between $94 and $232 per metric ton of CO2. Oldham says the company currently has a lot of startup costs. In addition to Occidental, some of Carbon Engineering's other investors include Bill Gates, along with oil giants BPH and Chevron. For a company whose main goal is to suck carbon from the air, partnering with oil companies seems counterintuitive. But Oldham maintains it's been an asset.
The climate problem is really, really big. And to sort it out, we're going to need to bring all the players that have expertise and knowledge. So, for example, our partnership with Occidental, we can capture CO2. That's what we, Carbon Engineering, do. But what do you do with the CO2 afterwards? It needs to be safely, permanently stored back underground again. And Occidental has the experience of doing that. Secondly is scale. We are a small company today in British Columbia and Canada, But we want to build these massive plants worldwide to make a material impact on climate change. But we need help from companies that can assist us with that process. And then the third point, and I have to be blunt on this, government policy and support has simply not been there. So the commercial sector here is moving faster.
To tackle the problem of scale, Carbon Engineering is also licensing its technology to other companies. Climeworks is another company working to solve our carbon problem through direct air capture. The company operates 14 direct air capture plants across Europe and is building its largest plant in Iceland. Currently, Climeworks plants are capable of capturing about 2,000 metric tons of CO2 per year. The Iceland plant called Orca will be able to capture 4,000 metric tons of CO2 per year once it's completed in April. Climeworks' carbon capture process differs from that of Carbon Engineering's in that it uses a solid to absorb the carbon instead of a liquid. It looks like this. CO2 from the atmosphere is drawn into what's essentially a large fan and is captured on the surface of a filter that sits inside. Once the filter material absorbs as much CO2 as it can, the collector is closed and heated to around 100 degrees Celsius, causing the pure CO2 to be released and collected. Climeworks says it's able to power its facilities using renewable electricity or energy from waste. The company's Orca plant will be entirely powered by a nearby geothermal power plant. For the storage part of the process, Climeworks has partnered with carbon storage company Carbfix. After the CO2 is collected, it's mixed with water to form what's essentially hot seltzer. The mixture is then injected deep underground into a basalt rock formation. When the CO2 eventually mineralizes, it's permanently locked underground. But costs are still high. To capture 1 metric ton of CO2 runs the company between $600 and $800. Climeworks hopes to bring that cost down to between $100 and $200 per metric ton within the decade. Part of the reason the cost is so high is because building a plant is expensive.
The expected cost varies from just 6 figures for a demonstrator, and then it goes into the several millions for a plant of the size we're currently building. And obviously, if we're trying to build something, at million-ton scale removal capacity per year, we're talking hundreds of millions. We have built a Tesla Roadster, and we have proven it works, but it's still expensive, and we now rely on people to buy that so there can one day be a Tesla Model 3.
Some people have already answered the call to action. Climeworks began offering its carbon dioxide removal service in 2019. Anyone can sign up on their website, pay a subscription fee, and have carbon dioxide removed in their name. Companies like Stripe, Shopify, and Audi have also partnered with Climeworks to remove carbon from the air. Microsoft, too, has invested.
We bought 1,400 metric tons of CO2 removal. We also went and invested in a new carbon capture facility that they're building in Iceland.
Like Carbon Engineering, Climeworks also sells the CO2 it captures. The company's first customer was a greenhouse in Switzerland, which used its CO2 to grow vegetables. In 2018, Climeworks also entered into a partnership with Coca-Cola Switzerland to provide CO2 for its sparkling water. Climeworks CO2 is also being used as a feedstock for synthetic fuels. But one thing that the company's CO2 is not being used for is enhanced oil recovery.
We actually don't support EOR. It's also something that is limited to the US as a kind of discussion. So it's something that in Europe is not commonly done, and we certainly will not engage.
At this point, both Climeworks and Carbon Engineering say they're pre-revenue and will likely need policy changes to be successful long-term. There are already some policies to address carbon capture. In the US, one of those policy initiatives is a tax credit known as 45Q, which was expanded in 2018 to include direct air capture. 45Q provides a tax credit of up to $50 per metric ton for capturing and storing CO2, and up to $35 per metric ton if the captured CO2 is used for feedstock in things like fuels or for enhanced oil recovery. Between 2010 and 2019, 10 companies claimed more than $1 million each in credits. As part of the tax credit rules, companies were supposed to come up with monitoring plans for the CO2 they captured and submit them to the EPA, but a report released last year showed that the majority didn't follow EPA requirements.
For the vast majority of credits, 9 out of 10 given, the companies simply never submitted their monitoring plans to the EPA, and the credits were given out anyway. Along the way, a number of oil companies, led by ExxonMobil, actually began to lobby to change the regulations to loosen that somewhat. And so companies now don't have to submit their plans to the EPA. They'll have the option of using a third-party contractor to kind of have their own verification process to make sure that it's staying underground. The IRS will not disclose who has benefited from this tax credit or how much they've gotten, but by looking at which plants are eligible to claim the credit, we're able to determine that ExxonMobil was in a position to claim at least a couple $100 million, which may have been the largest share of any company under this tax credit.
Low carbon fuel standards, like those enacted in places like California, Oregon, and British Columbia, could drive greater demand for synthetic fuels, like those made from the CO2 captured by Carbon Engineering and Climeworks, as well as demand for the company's carbon credits. Others have suggested that a carbon tax could help get carbon capture technologies off the ground. Today, 25 countries around the world have a national carbon tax, but the US is not one of them.
Ultimately, the use of direct air capture is going to be decided by the policymakers. When the policies incentivize stopping an emission and don't similarly reward removing an emission, naturally the tendency is that you'll look at technologies that can stop an emission if that's cheaper. Our job at Carbon Engineering is build the tools and be ready with the tools so that we have the technology when the policies are in place.
Pretty much everyone agrees that for direct air capture to make a meaningful impact, it needs government support. As part of his $2 trillion climate plan, President Biden has said that he will double down on federal investments and enhance tax incentives for carbon capture and storage technologies. But Microsoft stresses that large corporations also have a part to play.
When you look at really the way that you can incentivize through financial vehicles new markets to develop, there's really three legs to that stool: as a customer, as an investor, and as a donor or a philanthropist. And so we're doing the two that we really have the power to act on, and every corporation that can do that should do that.
Another thing that many experts agree on is that while direct air capture and storage is an important tool for reaching our climate goals, we shouldn't put all of our eggs in one basket.
If you do the math, you have to deploy all carbon removal opportunities to their maximum capacity. That is the only way that we will reach our overall societal climate targets. Direct air capture is going to be an important part of how we reach a net zero carbon economy, but it has a lot of engineering challenges ahead of it, and we need to be clear-eyed about that. Otherwise, there's going to be a lot of dashed hopes and missed targets as we go from 2020 to 2030, 2040, and 2050.